So in this video, we're going to see questions from exercise 13.2, which belongs to chapter number 13, surface areas and volumes. So here we're going to see question number 3. Let's read what the question says. Let's try to zoom in a bit. Okay. So a metal pipe is 77 centimeter long. So as we read the question, we try to visualize and map all the information that is given to us. So it says that the metal pipe is 77 centimeter long, which means it's the height of the metal pipe. So I'm just going to quickly make a mark here. So this height, okay, let's use a straight line. Yeah. So this height is I'm going to write here h. H is equal to 77 centimeter. Okay. Yeah, h is equal to 77 centimeter. So the metal pipe is 77 centimeter long. Okay. Now the inner diameter of a cross section is 4 centimeter. So what is cross section? Cross section, let me highlight this word. Cross section is nothing but the circle. Okay, this circular. So the inner diameter of cross section is 4 centimeter and the outer diameter being 4.4 centimeter. Okay. So how you visualize this is, if you observe this cylinder, okay, if you observe this cylinder from the top, okay, this is how it will look. I'm going to try to visualize it here. So you're going to see two circles, okay, circle number 1, and you're going to see another circle, circle number 2. And what it's saying is that the inner diameter, let's read it again, the inner diameter of cross section is circle, okay. So the inner diameter of the cross section is 4 centimeter. So let's try to draw that. So this will be the inner diameter. Okay, I will draw just this as the inner diameter. Oops, let's draw a straight line. All right. Okay. So this inner diameter is given to be 4 centimeter. Okay. And the outer diameter is 4.4 centimeter. So if we extend this basically, then you'll get the outer diameter. So this like this. Okay, this is quite funny now. So this outer diameter, or let me use a different. Basically, it will be the same center with different diameters. So I don't want to use a different. But anyway, the outer diameter is given to be 4.4 centimeter. So this is given to be, okay, 4.4 centimeter. Okay, so remember that this pipe, okay, this pipe is something like this. Okay, it has this distance in between. It is not just one, it is not just a one pipe which we typically consider our right circular. It is not just this one simple right circular cylinder like this. Okay, it has two different circles. So the way we construct this is, there will be one more circle here, okay, and there will be one more circle here, and that will also, sorry, and that will also get connected to each other, okay, like this. So this is how this metal pipe looks even from the inside. Okay, there are two cylinders, one above, one inside the other, and this top view, okay, if we look at this from the top, then this is how it will look. This is how it will look. That's the top view of the circle. Okay, so this inner diameter is 4 centimeter, this one, and the outer diameter is given to be 4.4 centimeter. Okay, that's it. So it's a little bit different than a typical right circular cylinder, but nothing very complicated. I think the visualization is very important. I hope you guys have understood that how this inner diameter and the outer diameter will look like. Now what the question reads is, find its inner curved surface area. So we have to find the inner curved surface area of this small cylinder. Let's use a highlighter to just this cylinder. This is the inner curved surface area. Then you have to find the outer curved surface area. So outer curved surface area will be this outside cylinder. Okay. So okay, this one, the outer bigger one, that curved surface area, and then the total surface area. So in order to calculate total surface area, we have to consider only the outer cylinder and then this outer circle. Okay, the bigger circle of 4.4 centimeter in diameter. Okay, so that is what we have to do. Let's start with this first topic, or the first sub question, inner curved surface area. So we all know what is the formula for inner curved surface area of a cylinder. That is equal to 2 pi r into h. So h is already given to us. Okay, h is 77 centimeter. going to substitute the values here. So that will be equal to 2 into pi is 22 by 7 into r. So what will the inner radius? The inner diameter is 4 centimeter. So the inner radius will be half of it, which is 2 centimeter. So I'm going to write here 2 into h is given to us. H is 77 centimeter. So into 77. Okay. So very simple. That is equal to 2 into, so 22 into 2 into, so this 7 and this 7, they will cancel each other out. So that will be 11. 7 into 11 is 77. And that's it. That is equal to, so 2 into 2 will be 4. So 4 into 22 into 11, that is equal to 88 into 11, and that is equal to 11 8s are again 88, 81 carry, 11 8s are 88 and 8, that is 94. Yes. So 94, and what is the unit? Everything is in centimeter. So that is centimeter square. It's very important. You have to be careful that all the variables that you are using, these variables r and h, they have to be in the same unit. If they are not, then you have to bring them into one unit, either centimeter, meter, whatever is given to you, and then go for the calculations. So 948 centimeter square is our inner curve surface area. So let's make a note of that. This is equal to 948 centimeter square. Now next we have to calculate the outer curve surface area. Okay. So for outer curve surface area, we are going to use the outer diameter, which is 4.4 centimeter, and the formula is going to be same. So in fact, let's do one thing. Let's create demarcation here. Okay, and let me write here inner. Oops. Okay. Let us write here inner curve surface area. I'm just going to write here SA, and here I'm going to write outer. So outer curved, okay, surface area SA. So again, the formula is going to be same, 2 into pi into r into h. This is the formula for a curved surface area of any cylinder, right circular cylinder. The only difference is going to be the r. So r is going to be this outer 4.4 divided by 2. Okay, don't substitute directly. This is diameter. Okay, this is diameter. We have to do half of it to get the radius. So let's go ahead. That is equal to 2 into 22 by 7 into, that will be 2.2. Okay, half of 4.4 is 2.2 into h is 77 centimeter. So once again we have 2 into 22 into 2.2 as it is, and this will be 11. 7 11s are 77. Now let's solve this. That is equal to 44 into 2.2 into 11. Okay, so that is equal to, so 40. Okay, let's do 44 into 11. So 11 for the 44, 4 gone carry, 11 for the 44 and 48. So this will be 484 into 2.2. Okay, and now that is equal to what? Let's use a calculator to find that. 1064.8 centimeter square. Unit is very important. Without unit, this number has no value. So 1064.8 centimeter square is our outer curved surface area. Okay, this the bigger cylinder. Okay, outer curved surface area. So once again, let's quickly make a note of that. Now this is equal to 1064.8 centimeter square. That becomes our outer curved surface area. Now the third thing they are asking us to find out is the total surface area. So total surface area will be, so this inner cylinder is actually not visible. Okay, it's there inside the cylinder, but we don't see it from the outside. So when we want to calculate the total surface area, okay, when we want to find the total surface area of this metal pipe, then we have to use this outer cylinder with this outer diameter only. Okay, so it will be the curved surface area, outer curved surface area, plus pi r square plus pi r square for the outer cylinder. Okay, so let's come here now, and I'm going to write it down. So total curved surface area will be equal to okay, so the standard formula is 2 pi r h plus 2 pi r square. Okay, and this is all with the reference of the outer. I'm just going to write outer cylinder. Okay, when it comes to outer cylinder, That we are going to use the outer cylinder to do all these calculations. Now for the outer cylinder, okay, this one, for the outer cylinder we have already calculated the value of 2 pi RH, which is equal to this. So I'm just going to write it as it is. So that will be equal to 1064.8 centimeters square, plus all we have to do is calculate this value. So 2 into 22 by 7 into r is 2.2 the whole square. Okay, let's come back here again to understand. So this is the outer radius, so we are using this. 4.4 is the diameter, half of that is 2.2. And why 2 pi r square? Because this the top of the cylinder and the base of the cylinder, okay, or we can say the roof of the cylinder and the base of the cylinder. So pi r square here and pi r square here, that is 2 pi r square. Okay, so let's continue finding this. So this value we already know. We have to just do this calculations. So that is equal to 2 into 22 divided by 7 into, this is 2.2, okay, into 2.2. So once again we'll use a calculator to find the value of this entire term. So this is equal to, okay, 30.4 centimeters square. Okay, and you have to add this to this 1064.8 centimeters square. Don't forget this, the addition is important. And that will be equal to what? So 0.2, 1 gone carry, 5, 6 and 3, 9, 1095.2 centimeters square. This becomes the total curved surface area, okay, of the whole cylinder or the metal pipe that was given to us. So let's go up 1095.2. Yes. So I'm just going to substitute that value here. This is equal to 1095.2 centimeter square. Okay, and thus this completes our question number 3. So just to quickly revise, the important thing here was understanding the visual representation of this cylinder, that this cylinder actually consists of two cylinders, one inside the other, and this was the inner cylinder with the inner diameter of 4 centimeter, outer cylinder with the outer diameter of 4.4 centimeter. And then you find out the inner curve surface area, you find the outer curve surface area. And the important thing is, when you're finding the total surface area, you have to use the outer cylinder dimensions. Okay, so once again the key point is that how you visualize the given problem as you are reading the problem. If this visualization goes wrong while you are reading the problem, if you visualize the problem in an incorrect way, then your all calculations will go wrong. So you have to be very careful and very alert and very focused when you're trying to visualize the problem as you're reading the problem. So read every line carefully and try to immediately make note of all the key information, the height, the radius, the inner diameter, the outer diameter. Make notes of all these information given from the question into your visual representations. And once that is done in a very nice way, then finding out all these things is very simple and straightforward. All you have to do is just take a look at all these diagrams and keep on substituting the values. That's it.